Hello, everyone. Another day, another lecture. Today, first I wanted to make sure that I remind everyone again that we have a conference going on in Buenos Aires, 10th of November. And here, let me put that up there for a minute here. I'll move aside. 10th of November, in Buenos Aires, Argentina. Those who want to come, those who want to submit a paper, my recommendation, you start working on it now, at least, okay? So that's just a reminder. Okay, let me get that out of there. And today I'd like to talk a little bit this week. I mean, we had a massive week a couple of weeks ago. Last week we had a time dilated week, and this week we're gonna do black holes. Maybe we'll find out how that works. And one of the issues that comes up is, what is a black hole? Hopefully we answer that question today without a shadow of doubt, so everybody understands exactly what a black hole is and what role it plays in mathematical physics, especially today. I mean, it's one of the most popular subjects, and that's one of the reasons I chose it for today.
Do you know why black holes are so popular? Besides the fact that they're cool?
Well, I think it's that coolness in the sense that they're magical. They're magical in I guess they're magical from this point of view that here you have a zero-dimensional nothing, right? There's nothing there except mass, apparently, and it can swallow a sun, a star, and people kind of like that. They say, look, we got this big sun, it's providing us with heat and energy and all this stuff, and it turns out here's a black hole. It's more powerful than the sun. It can swallow the sun, like throwing, a coin inside the pocket. It just, boom, takes it away, a whole star. And then, another idea that is provided by black holes is that every single galaxy has one at its center. And the entire galaxy, according to mathematical physics, rotates around this black hole. And so people kind of look at that and say, that's kind of interesting. I like that. It's like magic. And then you got a couple more issues as well. Black hole is the entrance to a wormhole, takes you to another universe without you having to go at the snail space of the speed of light. You can shortcut that by going through a different dimension.
Real quick to that, do they say that you go faster or that the distance
No.
gets shortened?
What you're doing is you're taking a shortcut. The road is what changes. The highway is different.
So you don't move faster than the speed of light, you just take a shortcut.
Right. And so, maybe a good place to start is, what is a black hole? And why don't we start with visual aids here? This is what you see illustrated out there. This is a rotating black hole, whatever that is. I don't know. Is that like one of those stars for Christmas or New Year's that twirls around?
It's like a firework.
Or looks like what happens in my toilet every morning. Just takes everything down.
But that's not the black hole. That's the matter that the black hole is vacuuming,
sucking in there. Yeah, but
you
that's
can't really see a black hole.
That's one of the issues I'd like to clarify. Can we do that? And
earlier you said that it was zero-dimensional.
Yeah, you would think, and I think we're going to address that issue as well today.
Well, let's just lay out some properties of black hole. What is a black hole?
Let me show a couple more, and then we'll get into it. Let me get first the visuals, right? And that's one image. Here's another image, which is a little different. You can see that this thing is like a hole in space, I guess, and it moves around or things move through it. Any way you want to look at it. And here's a third vision of it, and this is, I guess, a side view. Like if you would, made a cross section of space, I guess. And as you can see, all the matter is falling inside the black hole, which allegedly extends. Here it's extending like a cone, but you should look at that as extending infinitely. It just goes, it's a bottomless pit. Okay, so those are 3 images we have of black holes, right? And again, they serve here. This is something I showed last week. Here you see it as an entrance to a wormhole. So the mouth of a wormhole is a black hole. And the question, and which goes to what you just asked a minute ago, is a black hole? How many dimensions does it have? Is it 3-dimensional? Is it 2-dimensional? 1-dimensional? 0-dimensional? How many dimensions does a black hole have? Well, if you look at this one, and that's the entrance, you would say that at least it has 2 dimensions, right? That looks like a 2-dimensional hole. And here I'll prove it to you. Here we have Bugs Bunny. He's got his hole here on Earth, and you would think that hole has length and width at least. Maybe not the height of Bugs, but at least a length and width. So we're talking about 2 dimensions, right? At least. Here's another vision of that, of the entrance to a wormhole, which also I showed last week. You can see how the...
Real quick to the Bugs Bunny.
Yeah, let's get that. Yeah.
Oh, it's still up for me.
No, it's okay. I'll put it back up there.
Is it accurate to talk about the dimensions of a hole, and instead of talking about the dimensions of the
earth,
dirt? Yeah.
Of the dirt, and that's one of the issues, because this is kind of surrealistic in the sense that you're turning the hole, which is just the mouth, the opening, into a physical object. It's like, are we talking about a ring here?
Yeah.
And okay, so let me show this last one here, which is the.
I guess it's like talking about the distance between the table and the wall. There's nothing there. You're measuring nothing.
Yeah, the measurement of you're measuring the tape itself that you extend. That's what you're doing. Well, here you have another vision of it. The mouth of those universes. That little hole you see there, that's the black hole. What what is it? The cylinder there, that connects it to the other universe. That's the wormhole.
It looks like a pinball machine.
Yeah, but the hole itself, just the mouth, that's the black hole. And again, I think you would say that has at least 2 dimensions. Okay. So I would think that as a minimum we have to say a black hole is 2-dimensional, or at least it's portrayed or depicted as 2-dimensional. Whether that's exactly what the mathematicians want it to be, I don't know. That's a separate issue. But how it's illustrated and portrayed, no doubt about it, is at least 2-dimensional. Okay, and they say that we have one also in the middle of the Milky Way, and you can see there, these are stars that have been mapped and projected on how they're going to spin around the center of the Milky Way, and they're saying the only thing that can cause such movement of those stars is a black hole. And so that's one of the reasons they came up with the idea that the center of all galaxies have a black hole in it.
Wait, what is this?
All these are stars that are rotating near the center of a galaxy. Okay, so each one of those, okay. And so they're saying that. See, you can see they're all like circles, the itineraries.
But is this an equation, or did they see this?
This
what are we talking about?
I'm not exactly sure, but I think this is a projected. In other words, they do a simulation, a computer simulation. You can look at the years there. Yeah, they're saying how the years are where these stars are gonna be near the center of the Milky Way, and they plotted their trajectories.
So they extrapolate the trajectories of stars, and they say, hold on, these things are all spinning around nothing.
Right, and so they
the center of a galaxy.
Correct, and so they come up with the idea that our galaxy, I think this is the Milky Way here, has a black hole in its center, and then they extrapolate that all other galaxies probably have one as well.
Like saying, since since the Earth goes around the sun and all the planets in our solar system go around the sun, if you were to remove the sun,
would they go around
and just have the planets going around, you'd say, okay, there's something there with the mass of the sun. We just can't see it. That's
correct. That's more or less what they're saying with this picture, at least with this extrapolation, right? And so we get to the key question today, and that is, let me put myself back in here. And what is this? We're saying here, what is a black hole? And these are some of the definitions that people have put out there. You're welcome to read some of them. I'm not going to go through them. You've probably read some of these, those who are familiar with my arguments. You probably read some of these in my paper on black holes. And essentially all these people depict or describe a black hole as an object. And what I'm saying here specifically is that they describe it as a black ball. Okay? So they're saying a star collapses, shrinks, but it doesn't go completely to nothing, to zero volume, to zero size. It shrinks and it stops at a ball. And you will see some of the descriptions here. Or,
you're talking about the origin of a black hole, right?
Yeah, I'm saying that
how
the origin, how they're made. In other words, the way today it's explained that you have this enormous star, at least 3 times as big as our sun, and it collapses. It shrinks on itself due to gravitational forces only. So it shrinks out of sheer gravitation.
You're saying it has so much gravity that it pulls itself in.
It pulls itself in, it compresses itself, right? It self-compresses, but it doesn't turn into absolutely nothing. It doesn't turn itself into zero zip, zero size, zero volume. No, it stops at the 8 ball.
Like actual 8-ball size?
One of these description here says the size of New York City. Now that's a little bigger than an 8 ball, right?
Pretty big. Yeah.
Pretty big still, you know. I mean, on a cosmic scale, it's nothing. But if they talk about the size of a city like New York, you know, I don't know how many kilometers New York has, but you're talking at least a couple kilometers there, you know, more than that for sure. And so we're not talking, the point here is we're not talking about nothing. We're not talking about zero size. We're saying it comes down to an 8 ball, an 8 ball, which is the size of New York City. Okay, so that's what you got to imagine. How big is that? Well, it's bigger than a basketball, bigger than a cannonball. Any others? Bigger than the Skylab, which is pretty big. You know, it's kind of like a ball out there.
But they depict it or imagine it as a really big city-sized sphere.
Correct. That's these guys, okay? And a couple of these come from NASA. So what are we supposed to say? If NASA tells us, I mean, it's a done deal, right? Well, NASA also has a contradiction with that because it also has a different kind of definition. And here I put it on the other side. Let me get myself in the center here. And they depict the black hole as a region of space-time. They say this thing completely collapses, disappear from the universe in the sense that it becomes zero volume, zero size, zero radius, zero diameter, 0, 0, 0, 0 all the way. Except weight, mass, really. Don't insult them. It's mass that they're talking about, and we know the difference between mass and weight. We learned that 2 weeks ago, right? Okay, so let's not get confused here. The point here is that there's 2 primary definitions or notions of what a black hole is. On the one hand, we have here on the left the black ball, and on the right hand, we have the region. Now, is a region the same thing as a black ball? Well, I don't think so. The black ball, you might locate a region on the black ball, and that's the number 8, right? And we call that the region where the number 8 is described. I can also talk about the region of my hand is the palm. The palm is a region of my hand. Each one of my fingers is a region of my hand. China is a region of the earth, right? So a region is always of something else.
Can you talk about the region of space?
Yeah, you can talk about the region of space, but then it's not a standalone object. That's my point. I mean, there's a difference between a black ball and a region of space.
Yeah.
That's my
Well,
point.
it's like the Bugs Bunny picture where you showed us. The hole is a region of
Of
the ground.
the Earth, right? And so you can't confuse that with a ball, and you can't say that hole is the same thing as my basketball. You know, it might have the same size, diameter, or whatever, but you can't say that hole that Bugs Bunny made there, just the entrance, right? That two-dimensional entrance is the same thing as a ball, because one is a region of the Earth, right? We'll say that's the hole. Bugs Bunny's hole is a region of the Earth. The other one is a standalone object that I can throw around, kick, and whatever. So they're two different things. And that's the problem we have here. The problem here is that the black hole on the left is a standalone object. And we can all understand that. We can say, look, a star collapses to the point where it becomes a small ball. We can all deal with that. The second one says something different. It says, look, it collapses so much that it disappears completely, and what remains is a region. We no longer have the elephant. Now we have his weight or his mass.
Is that like saying you have an inflated basketball and then you pop it, and then you're just looking at where the basketball used to be?
Correct. More or less, that's what we're saying here. We're saying that the perimeter or the boundary of that ball that's no longer there, that's the famous black hole.
Because they're talking about the area that is affected
Right.
by
Correct.
whatever effects they
Or the region of
like
influence.
Magnetism. Yeah, it's kind of like magnetism, where you're talking about a region because
Yeah.
anything within this region gets affected by whatever magnetism is.
Yeah. And
So
that,
you're talking about a region in that sense. I get it.
yeah, and so we have two different notions, two different concepts of what a black hole is, okay? So just keep that in mind. And so some questions come up. And these questions have been asked of the gurus of mathematical physics. What was it? The BBC asked several of these individuals. Max Tegmark, one of them, Larry Krauss, another one, Michio Kaku, another one. I mean, these are famous names out there, right? And these people were asked the following question. The first one is, have you ever seen a black hole? And they answered no, all of them. The second question was, what is a black hole made of? And this was strange because they all said, we don't know. And it's strange because they should have all answered the same, given the same answer. A black hole is made of mass.
Yeah, that's what I would
Period.
say.
I mean, you have curved black holes, which are rotating black holes, and they have angular momentum and charge and who knows what. But all black holes, all of them, without exception, because that is the definition essentially of a black hole, all of them have mass. And you say, why didn't all these mathematicians answer that question and say, look, a black hole is made out of mass?
Well,
it was simple.
But is that the accurate way of saying it? It's
Well, I don't know. You tell me.
No, but maybe that's why they didn't say mass, because it's not made of mass. It has
Why not?
mass.
Okay, it has mass. Why didn't they could have clarified that? They could have said, well, it's not made of mass, like you just said, but it's kind of it has mass.
Yeah, but that's not saying it's made out of it.
Well, what does it mean to have mass if it's not
like
made
a
of mass?
It's like a recipe. Cake has egg, but it's not made exclusively of egg.
Exclusive. I didn't say exclusively. I mean, if all that the cake has is egg, then we can say it's made out of egg. Right? I would think.
It's not a cake anymore.
Yeah, if it's made out of all chocolate, we would say, what is the cake made out of? It's made out of chocolate. Yeah. Nothing else? No, I just made a big block of chocolate. I call it a cake. Okay? And that's, I mean, if the only thing that a black hole has is mass, then you say, not only it has mass, fine, but it's also made out of mass because that's the only thing a black hole has, mass. Now the question, why didn't these guys answer that? And the answer to that question is that they would have entered into a circular argument. And a circular argument, as some people are aware, let me get that one out, that's the wrong one. Some people are aware of my arguments that here you have the circular argument of mathematical physics, and that's if a black hole is only made out of mass, and if mass is the quantity of matter, and if a black hole crunches and crushes all matter out of existence,
Well,
we have a circular argument.
where'd that new one come from? We never talked about that. A black hole crushes matter out of existence?
Oh,
I
yeah.
thought it was the ball.
Well, that's when it's a ball, but when it's not a ball, when in fact, you'll see this everywhere. You'll see that they'll say, yeah, it's a ball, but then those people are simply wrong because the great majority of them say, no, it's a region of space-time, because what has happened is this star collapsed so far that it crushed all matter out of existence. There is no matter in a black hole.
But that's when they're talking about a ball, it doesn't have that property, and when they're talking about a region, they do talk about it crushing matter out of existence.
Correct.
So here we're taking
the region version,
not the ball version.
Correct. Here we're talking about the region because obviously if it's a ball, then you would think that at least, right, it has some matter in there, but and these are the contradictions you will see. Some people will say, oh yeah, it compresses to a ball the size of New York City. And then the next sentence they'll say, yeah, a black hole crushes all matter out of existence. And they don't realize that they have a contradiction.
Yeah, that is a contradiction.
And they don't realize this.
I can imagine the ball kind of compressing.
Yeah.
But I can't imagine it compressing so much that it's gone.
But that's the contradiction, that they use these sentences in the same dissertation, and you say you've got a contradiction. How can you say it crushes all matter out of existence and then it ends up as a black ball? What is the black ball made out of?
Do
that?
they all say that it crushes matter out of existence?
A lot of it. It's very popular in the black hole industry.
Well, they always talk about black hole maybe not crushing it out of existence, but sending it somewhere else, like time or space.
It's through the wormhole.
Yeah, like you said earlier, either it sends matter, anything that flies into it, somewhere else.
Yeah.
Somewhere else in time, somewhere else in space, or it crushes it out of existence. That's three different things.
You get rid of the problem, so nobody asks any more questions.
Yeah,
that's what you're doing.
No one knows where the matter goes, but it went somewhere else.
As long as you dispose of it, throw it down Bugs Bunny's hole and you don't see it again.
You don't care where it went.
Or Alice in Wonderland down there, it's fine. Just get rid of the problem.
So, but they all agree that when matter goes into it, it isn't there anymore.
Right. It goes to the center, supposedly to the singularity, which is at the center, which is another zero-dimensional nothing. But it goes all the way to the center because everything's attracted there, right? Mathematically. That's why they come up with these ideas. And they say, there it goes, were the three, to another universe crushed out of existence.
Well, actually, I didn't even mention it. Another universe is the fourth one.
Okay, what were the other three?
Another time period into another time.
Give it to the next generation, the problem.
Another
I like that.
place in space, like the wormhole you talked of. So
get rid of your rubbish to your neighbor.
Somewhere else, somewhen else, another dimension, or out of existence. Those are the four. And
you disintegrate it completely.
Yeah, this is good.
Or you turn it into a region.
Oh man, I get even weirder. But all of these we're talking. So what was the ball one that no one seems?
Nobody uses the ball. The ball is something like NASA uses that in its website in two pages of its website just in case, not an error. And they're not the only ones who use it. In fact, I've got the statements there from several different places. But the idea of all these people is that a star shrinks, but it doesn't shrink completely out of existence. It just keeps shrinking. For some reason, it stops at a ball. And they have this ball idea, and part of that, I think, has to do with something I think Steve Crowder's attacks, which is escape velocity. I mean, if you have nothing from which to jump, you have no surface from which to jump, I'm not sure how you can talk about escape velocity, or how you can you can talk about it, but the issue is, how can you portray that? How can you illustrate that to someone who is out there? And you say, well, imagine standing on the surface of something. Yeah. Then we can all understand that. As long as you're standing on the surface of a ball. But if you say, look, there's nothing there, you're standing in a region. Yeah, what are you escaping? What are you jumping? What's your trampoline?
Okay, but from here on out, we're going to be talking about the region, right?
Yeah, in general, the idea that most of these people have, and especially if you go with the mathematics of it, I think it all points to the region version. In other words, there's nothing there. And that creates bigger problems as far as I'm concerned, because now you're not even talking about an object. You're talking about just man. You're not talking about the elephant anymore. You can get rid of the elephant, and what you got is a point, a zero-dimensional point for that matter. You get a location, and in that location you got tons of mass. And then what sense does that make to have tons of mass in a region, and there's nothing there? There's no physical object because all matter has been crushed out of existence. So we end up with some kind of weird situations. And from a mathematical point of view, they can do whatever they want. They can do the equation and show you how this thing collapses to a zero-dimensional singularity, and that's fine. They can talk about whatever at the math asylum. But in physics, that's completely banned. It's completely outlawed. You can't talk like that in physics. You can't talk about zero-dimensional nothings because there is no such object as zero-dimensional. And so that's one of the issues. The other issue also brought up here by Hans is, how many dimensions does a black hole have? And that's another monster because these people come up with all these versions. They come up with, first it's an illegal question, they say. You shouldn't ask that question. It's an unscientific question.
That's always the out of the gate answer.
Yeah, you're asking an unscientific
Mom,
question.
why is the sky blue?
Yeah,
don't ask those things.
Just eat your soup and shut up. The second one is the opposite. It has many dimensions, infinite dimensions. And the third one is that it's got zero dimensions, okay? And here, this one is probably the only one that's correct because here you have a statement that says, Leonard, and this is a guy who wrote a paper that's been published, right? And it confirms what Schwarzschild did hundreds of years ago, in 1915. And what other people have held for a long time, and that's that he showed that the black hole has the black hole radius is zero. Okay, I mean that's clear, right? It has no dimensions whatsoever, and they refer to that zero-dimensional nothing as a singularity, and that's okay in mathematics. It has nothing to do with physics. And then also it could have one dimension because you take the singularity, which is zero-dimensional. Think of a point. That's the best you can come up with, a Euclidean point. And you let it, you take it and you scan it. You let it move. And as it moves, it describes a one-dimensional line.
So we're talking about time.
Well, not only that, we're talking about a zero-dimensional nothing creating a one-dimensional line. Now, what sense does that make? How did the zero-dimensional become one-dimensional? How does the one-dimensional become two-dimensional? Well, all that's done with this Euclidean nonsense that says, if you want to know what a plane is, all you got to do is scan a line. That's okay in mathematics. That has nothing to do with physics. And that's what they're doing here. They're scanning a zero-dimensional nothing, and they end up with a one-dimensional stick, if you can even imagine such a monster.
It's like if it's like trying to scratch the table with zero dimensions. You can't really indent anything. That's what they're talking about. If you're talking about a line, they're essentially scratching space.
Yeah.
But you can't really indent anything or do any damage or
it's
have any effect with zero dimensions. I mean, if you have a zero-dimensional something, it by definition, it has no effect on anything else. You think, right?
Yeah, for rational people, that's true, but for irrational people, that's not true, obviously. Then we have that black hole can also be two-dimensional, and that's the pictures I've showed earlier. The other pictures, you saw that they were at least two-dimensional. And then obviously, they have this idea that a star turns into a sphere the size of a city, and that's the three-dimensional version. So a black hole can have all these dimensions, and with that they cover every single base. And that's the problem.
But are these different people?
Sometimes they even contradict each other. They don't care.
Well,
they just say
the problem, but if they contradict themselves, because if one person always only talks about zero dimensions, and another person always talks about one dimension, they're not contradicting themselves if they keep using the same one. They could have disagreements with how many dimensions.
But we have a problem because we go to the black hole conference and there's many. I think one every year, at least one. There's probably several, And you say, what do they do at those conferences?
Yeah, well, that's a different.
I mean, haven't they resolved how many dimensions a black hole? Haven't they put their heads together and said, look, this is the official version. It's got 0 dimensions or it's got 3 dimensions, whatever. But for them to have today all these different representations and all these, I didn't take these out of nowhere. I took them out of official sites. And so if you say these guys get together, what do they talk about? Don't they at least try to get a handle on how many dimensions a black hole has?
If they don't even have the common ground of how many dimensions a black hole has, what common ground are they discussing?
No, and it points to the definition of black hole. What is a black hole if it covers every base? It has 0, 1, 2, 3, none, many. What is this? What kind of monster is not even God has so much powers? I mean, if you say how many dimensions does God have, you say, well, 3-dimensional. He's a guy with a magic wand. He's got 3 dimensions. No problem. We can draw God 2-dimensional, 3-dimensional. But to say God has 1, 0, many, none, what is that? Then what is God? And this is the same thing here. The black hole is the god of mathematics.
I thought energy was.
Well, I think black hole is replacing energy is a 19th century concept, so it's over and done with. Yeah, people like Lord what is it, Rayleigh? He used to deal with these things. People in the 19th century.
We're on to bigger, better things.
Yeah, that was stuff for them.
Stuff.
We're beyond. That's almost classical mechanics. Now we're dealing with real stuff, with black holes. And so this is the problem. The problem is we don't have a definition. We don't know what it's made of.
Definitions.
Or none at all, because they don't really have one where they can really sink their teeth in. This guy says one thing, the other guy says another, and you say, haven't they reconciled all these things? Haven't they debated these things and say, look, we got to show a single front, or an official front, the party line, and say, look, this is a black hole, and this is how many dimensions it has, this is what it's made out of, and we have all the questions answered. We have none of those questions answered. And so these people talk about the math, but they never talk about what it is for the black hole is for the purposes of physics. How many dimensions it has, what it's made out of. If people like Max Tegmark and Larry Krauss cannot answer a straightforward question, what is a black hole, what it's made of, how many dimensions it has, then we got a problem. And especially, I'm sure none of them can define what a black hole is. They'll probably say, oh, we don't know, we're still investigating. That's probably their best answer.
But is it, I guess, accurate to say that they all agree on the effects of a black hole, and they just don't know why it has those effects?
There's two primary effects attributed to black holes, and one of them is that stars revolve around nothing, and so the notion there is that there is something there we can't see. And they say all these stars are revolving around some big mass because that's the only thing that they can think of. Again, that shows that a black hole is entirely made out of mass. That's the only variable that they put in their equation. Big mass in the center, and they say that's what's causing this thing to go around. That's one. The other one is, that they look at stars, they're losing a lot of matter from their surface, and they say, what's sucking it? And they say, oh, it's the black hole. There's got to be a black hole nearby that's sucking all this matter from the skin of this star. And so those are the two ways that they come up with these ideas. The third one is more or less like the first one, and that's that the center of a galaxy has a black hole because all the stars are near the center are revolving more or less around, something that seems to be there.
Is it accurate to say that because they notice these effects, that planets revolve around nothing that they can see, and that stars get their matter essentially vacuumed by nothing, they do calculations to discern what the forces are that this nothing should have, right? So they essentially give this nothing, this something, whatever. They just calculate the effects that it has, and then they say, okay, if these are the effects this black hole has, then with these effects you could also time travel, dimension jump, and all this stuff. It's like they're extrapolating from the fact that it can the planets revolve around mass. I mean, it has so much mass that it can do planet. It can essentially lasso planets and suck the skin right off of a star. If it has that much mass, what else could that much mass do? And then you get this whole list of weird effects that they then extrapolated out of that. Is that what happened with black holes?
No, what has happened, I think, is in reverse. They needed to explain what happens to a star which is much bigger than the sun, for example, right? And so they look at mass. That's the only parameter. Essentially, that's why it's unfathomable why they wouldn't say it's made out of mass, straightforward, or it has mass, whatever. Because that's all it has. And all they're doing is they need a variable in an equation. They say, we need to put something in here. And they say, let's put mass. And so they put lots of mass. They say, with a lot of mass in this equation here, we can produce the effect that we need. And they do the same thing, by the way, with dark matter. We need mass. We need kilograms.
We need kilograms here, here, and here.
Correct.
And
then we can explain or justify why a galaxy rotates this way, why this star is revolving seemingly around nothing. And they need that big mass. They need that big weight in there. And so that's all it is. It's just weight that's put into an equation.
But that's what I'm saying. Because they have so much weight, they then extrapolate, okay, if there were a dot that had this much weight, then what other effects could it have? And then that's when they talk about event horizons and time travel and space travel and dimension travel and all, and sucking things out of existence. Where did they get all the other things?
I think all that, they just give it to Hollywood and they say, you take over now. We done our math, we done the scientific part, we did the calculations, and this is what we came up with. And then they say, now give it to the rabble, to the masses, to the pleb.
But you said that they said that it crushes matter out of existence. That has nothing to do with planets revolving around nothing or sucking off the skin off of stars. So where did they get the other effects?
The other effects, again, they get them through, well, at least the two that you mentioned are from observation.
Yeah.
Okay, those are from observation.
So those are the ones we know, quote unquote.
But then they extrapolate, they say, well, if you have all this runaway gravity, or this infinite mass runaway gravity, what effect would that cause on something? So now they do more calculations. Yeah. And now they say, okay, how does it affect time? And so they come up with all this nonsense where, if you fall into a black hole or the astronaut goes into a black hole with a ship or whatever, and he takes a clock with him, what does he perceive? What do you perceive as the observer from far away? And they go into this time dilation, twin paradox kind of nonsense. And so they have to make sense of that. They say, look, this is what the equations would say. And from that, they extrapolate some of these new notions that they build. They hammer this nail in the air, and now they cling to it, they step on it, and they hang another one up above, and they're just climbing in, nails up in the air. And that's the way all this is done. They just keep doing equations on stupidity, because they've got nothing else to do. One of the questions my son asked a couple weeks ago when we were discussing some of these things, he said, what does a theoretical physicist do all day long? I mean, here you got 365 days a year, right?
It doesn't have to be theoretical, just any.
Oh yeah, just any of these, or mathematician. I mean, they're at the university, right? And maybe they teach math.
Yeah, besides teaching.
Yeah, besides teaching, what do they do at their offices? Just drink coffee and talk nonsense? I mean, what do these people do day after day after day? Do they do equations? What do they do? And I think we'd all be surprised at what we're paying for.
But back to the effects of a black hole.
Yeah,
that's kind of what I was getting at. The fact that they observe two effects: the fact that planets go around nothing, and that the matter from stars get sucked into nothing.
Yeah.
So we have those two effects. Then they put in an answer to why these two effects are taking place, and then from that answer they then extrapolate more and more and more and more, right?
Right, more or less it's like that. But again, a lot of that, they kind of hint. The popularization magazines say, oh, look at what so and so said, and it could be like this, and they start dreaming out loud. And then Hollywood gets that and say, oh, I can make a movie out of this, and the thing gets ballooned. Hollywood loves it because it's all, science fiction, but they say, no, this is the documentary. This is science.
It actually makes more sense.
But the mathematician
kind of get these extra effects kind of sounds.
But you know what the mathematicians do? As soon as you say, look, you guys are saying this, this, and this, and that, and they say, no, we're not. This is the popularization magazine. This is Hollywood. We do math. We do equations. And the only way to understand all this is through the equations. You got to take a course in math in order to understand what we're really, really, really talking about. And you say, well, what about all this other stuff? I say, well, that's the rabble, the peasant version. We give that to the peasants there, ignorant peasant. They discuss in circles. They illustrate this stuff. We don't do that. We just do math.
We do the truth.
Yeah, they do the truth, and if you want to know the truth, you got to take math, because they say they can't put their equations into words. Language is terrible to express what the equations are showing. That's their argument. And so, like I say, there's miscommunication. There's the communication between the mathematicians and the world out there is completely severed. And there's also an issue of the fact that these people are the question is whether these people are talking physics. Do they have any business making statements about physics, about the real world from their equations? Is this a valid thing? Is mathematics the language of physics? I mean, if they can't put into words what their equations tell them, is mathematics the language of physics? I think it's a valid question.
Does it help us at all if you can't really make sense of what the equations are?
Because we have to explain the real world. And hopefully Mother Nature out there, she's not doing math. I don't think she went to school. I don't know if she knows what a number 5 is. What she does every day is move objects, invisible objects, and that's what you got to explain, how she does that magic.
But it goes
how do numbers help us?
Well, it goes back to what we talked about last week, where if you have an aggregate of descriptions, if we have enough patterns and descriptions of how Mother Nature does it in excruciating detail, then it'll be self-evident. Then we'll be able to kind of go, okay, I see how she does it. Like if we calculate the exact size and mass of a black hole and the effects, it's like once you can make the realistic movie of it, then the explanation is kind of self-evident. Maybe something like that.
Yeah, but see, they never get to explain anything. Yeah. I mean, it just look at the entire 20th century. I mean, you would say, we made all these technological advances. We have computers now. We have cell phones. So many things that we've invented. They cannot explain a single phenomenon, not rationally. And they say, well, we can't, again, their answer is we can't put our equations into words. And then the question is, then is mathematics the language of physics? Because physics deals with what Mother Nature does out there, and she does everything with objects. She doesn't do it with math. With math, you can describe what she's doing, but you can't tell me how she's doing her magic. For that, you got to make assumptions about what invisible objects she's using, to do light, to do gravity, to do magnetism, etc. And so this is where the problem is. The question is whether this math that they use to do a black hole, does that represent the real world out there? And it gets scary because these people are telling the astronomers, look, our equations tell us that there's a black hole. Go to look for it. And the guy says, I look and I don't see anything.
That's just mean. That reminds me of...
Go look for it.
It's like when we used to play with our little cousin, and she wanted to play video games with us, and we'd give her the controller, but we wouldn't plug it in.
More or less.
It's like, yeah, look for it. Yeah, keep looking. Oh, no, it's there. Keep looking.
This is the problem. The problem is, dark matter, conveniently invisible and heavy. Black holes, conveniently invisible and heavy. Go look for it. And so, they're going to spend eons just looking for it. And they always give you the same answer. They say, look, the only way we can prove the existence of black holes, the only way we can prove the existence of dark matter, of dark energy, all these ghosts out there, is by looking at visible matter. Yeah. and extrapolating, interpreting that there is some invisible mass, because that's the only word they have, mass, that is causing these phenomena.
Is that kind of like with doctors when they put radiated materials in your bloodstream so they can then see the effects, see the path that the radiated material.
I wish they would do that with black holes. Just put something in the black hole so we can see it.
But that's what they're talking about. They're looking at the matter that it sucks off of the star, then they follow the matter swirling around nothing. So they're like, it's kind of like the radiated material where they go, okay, we don't know what the black hole looks like, but we can tell you what it does.
Yeah, and again, if that's the only explanation, mass, fine.
Like, what's the shape of its effect?
Yeah, but if there is another explanation for that does not involve mass, which is the case of the rope hypothesis, then all that dies sudden death tomorrow morning. You know, it's just gone. The problem here is that they only want to explain dark matter and black hole phenomena, what they observe out there indirectly. They only want to explain it through mass. That's the only explanation they have. And, you know, if you take away mass, they're dead. They don't have a physical mechanism. They never will have one because they're always doing it indirectly. They're trying to prove it through their equations, through indirect observation.
Why didn't they answer it by talking about a gravity well? Like, you know how the sun, they talk about the sun pushing down the canvas of space? Yeah. Can't they just talk about a black hole, or, you know, when they're talking about the effects of why planets roll around nothing? Can't they essentially just have an indented canvas with nothing in it?
And they do that. They do exactly. They illustrate it. In fact, where was it? Number 3 here. Watch it. Here, I'll show you. That's exactly what that is there. That what you're seeing there is the canvas being pulled all the way to infinity. You've got to look. There's no tip of that cone, okay?
Yeah, but we're not talking about mass there. We're just talking about a shape of space.
Shape of space. Yeah, all I'm saying is mass again.
I'm saying you can explain it with a shape instead of just putting kilograms there.
Okay, but in a way, what they're saying here, it kind of has that in there because they're saying, look, what the mass really does is distort space. It causes this enormous, infinite depression, and everything just falls in there. You know, like if it's in the center of the galaxy, all the stars are, you know, trying to get around it, and they're being sucked in there. But it's fortunately they're spinning around, and it's the centrifugal motion that keeps them from falling into the black hole.
Yeah, you know what
being swallowed by the black hole.
Whenever we talk about gravity in those terms, I always imagine at Walmart the donation. They have this donation thing where if you put a coin in and
it rolls around. Yeah,
that's exactly what I always
imagine.
Yeah, it's like an inverse cone.
And that's essentially what these people are saying for the black hole. It's just that if you can imagine it, they're just saying it's got infinite mass, which is also kind of weird because they talk about black holes having different amounts of mass. You know, I mean, how much is infinite plus 1? How much is infinite minus 1? I don't know.
But do they all say that it's infinite mass?
Essentially, they say, you know...
like a lot of mass is different from infinite mass. Because I can imagine a star compressing on itself and getting more mass, but at what point does it become infinite? At what point do the numbers just kind of get the little sideways 8 symbol?
It's all word wizardry. That's what it is, because they talk about sizes of black holes, and they're telling you that those same people are telling you it's a region of space. There's nothing there. It has 0 dimensions. But they talk about the size of black holes. They're saying, oh, we have a small black hole and a big black hole. What do you mean small and big? Well, what the hell is that? What meaning can that possibly have, big or small or size, in the context of a region?
Because they're talking about effects. They're talking about how far-reaching are the effects of this. You know,
that's why
like with magnetism, we have a very if it's the same. You have 2 magnets. They're the same size, but one has a wider magnetic field. Then you can say the magnetic field of this one is bigger, even though we're talking about just a region, not.
Yeah, in that sense, yeah. But see here, in the case of magnets, you can say, look, I've got an electromagnet, very powerful, and there's something physical there. In this case, all matter is crushed out of existence. If it's crushed out of existence and only the mass remains, what is the black hole accumulating mass, whatever that is, day after day after day? Just this one's bigger than the other one because this one swallowed more objects and it has more mass, whatever that means. Again, what did it swallow? What does it have? What ghost is this mass thing?
They also talk about black holes emitting matter or radiation.
Yeah, you have that's
things come out of the black hole
called Hawking radiation. So Stephen Hawking, our late guru who died a few weeks ago, he came up with Hawking radiation, which means that at some point, I guess the black hole hiccups and spits out all the garbage it swallowed, and it just throws it all back out.
But no one adheres to that one?
Oh, yeah, it's proven. It's
that
proven.
one's also
It's
that
proven.
one's been proven? I love that sentence. It's been proven.
It's been proven. It's all, forget about just guessing. This is not guessing. They've proven that black holes spit out matter just like they swallow black. Otherwise, what would the astronomers be looking at? Yeah, but if you say, look, there's a possibility we can find one that spits out, and tomorrow you'll find an astronomer who will say he proved that a black hole spits out matter, and he'll get a Nobel for it. Forget it. He'll prove that that Hawking radiation is a reality. So I don't know what to expect from all this. All we can say is that we have no definition. We don't know how many dimensions a black hole has. We don't know what it's made out of. We think it's made out of mass, but since
no one wants to put their hand in the fire for that.
But since mass is the quantity of matter, according to one of the definitions, and I guess that's what they're referring to, that it's swallowing all this quantity of matter.
Like atoms?
Yeah, like atoms and so on. So now it crunches them out of existence. There is no more matter, but you still have mass. What is it that has mass if mass is one of the two? It's either the acceleration, the resistance to acceleration of what? Of mass? Or it's the quantity of matter. How can that possibly, if the black hole crushes all matter out of existence? What do we have? We have absolutely nothing. And so the issue is, how can you accumulate a whole bunch of nothings and cause effects on real stars?
And you can't have it crushing matter out of existence, because then they turn around and say that it shoots out matter from the top and bottom.
No, it shoots out mass, I guess. I don't know how it shoots out. What does it shoot out? Yeah, that's a good question. I mean, was it spitting?
What is it spitting out?
It's spitting out mass, whatever that is.
Spitting out kilograms.
Which turns into energy, probably, and so on and so forth. I mean, again,
it feels like they're using every word interchangeably.
Yeah, it's a question of language. It does come down to language, because if they define their terms, they're dead.
I mean,
and so they just say they don't know what mass is, what energy is, what time is. It's great for them, because as long as they can't define these words, they can use them.
But they don't say that they don't know. What they do is they use circular definitions, like energy is mass, mass is velocity, velocity is distance.
Well, not true, not totally true. If you go and look up these words, like on the Wikipedia, or even at the Stanford dictionary, what is it? Not the encyclopedia of philosophy. They analyze these subjects, and whichever word you look up, you'll find the same answer. We don't really know, or there's several definitions, or this guy says this and the other guy says that. That's all they say. You will never find, a straightforward. This is what we mean by energy. This is what we mean by mass. No, you won't find that ever. And that's why to this day we don't have a definition for time, for mass, for energy. We have 10 definitions for each of them. And they say, well, this guy uses this one, this other guy uses that one. And we don't have, a solid definition that everybody can use consistently.
I feel like they could literally be like using the words in a gibberish manner. and just because they have authority, you just accept what this, like I could say, there's energy in the universe, and it attracts matter, and matter gets velocity when it gets attracted, and I can just come up with anything using these words, and it sounds fancy, and if I have a Nobel Prize, then But that sounds kind of too simplistic. Like no one would believe that. That's
But the
actually
question is
happening.
that people accept these.
Like what
these,
do you like? It can't be that that's what's going on.
Yeah.
that sounds
Yeah,
too
that
dumb.
is.
That sounds way too dumb.
No, but
There's
people
no way
are
that's
dumb.
what's really
Yeah, that's what's
And they're just
exactly.
making up words and making up definitions, and people are just kind of nodding their heads, or no one's listening.
Yeah, I think it's both. Or they're listening, they don't understand what they're listening to, and they just nod and they say, "Oh, he's such an eminence. I
It's-
wish I had,
It's
had
funnier,
his
actually.
intelligence."
It's
You
actually
know.
funnier. It's 90% of people aren't listening, and the 10 that are listening want to noble themselves, so they tout the party line.
Yeah. It's the Emperor's Clothes.
Yeah, that's what it sounds like.
Story tale, all over again. The problem comes down to language, and again, the black hole. We don't know what it is. We don't know how many dimensions it has. We don't know what it's made out of. And we're talking about big names, celebrities who can't tell you what these things are or what they're made out of or whatever. And you would think with so many conferences out there, they would have settled these issues by now. And none of them have been resolved. And so if you ever get in touch with a mathematician who vouches for black holes and swears on his mother's grave, just ask him, please define the term. What is it made of? Ask him the same question the BBC asked Michio Kaku and Larry Krauss and Max Tegmark. Ask them the same question. See if they can answer them. If they can't answer them, say, you don't know what a black hole is.
But could it be that they're all good at math, but bad at kind of like you said, putting the math into words? Like they're not very good wordsmiths in that sense. Like maybe that could be the case.
But if we have that for energy, we have that for time, if we have that for every equation these guys write, what should we conclude? That math is not the language of physics
Or that they're
or
bad
of the real world.
Or they're really bad at explaining things.
No, because they claim, they at least they claim that, all the way since Niels Bohr and Werner Heisenberg, they said, you can't put this into words. Don't even try.
Yeah, that's what I'm saying.
And so if you can't
So
put
they
it into
use-
words,
so
then
they use
what are you
metaphor.
doing? They live with metaphors, analogies, similes, etc. They don't really have an explanation that you can take to the bank. You cannot explain to your kid any of these things because the answer is always take a course at the university and you'll understand what we're talking about. They can't put it into words, and if they can't put it into words, is mathematics the language of physics?
I wanted to end it with a Quora question.
Okay,
That's
go
a nice
ahead.
way to end them.
Yeah.
This is a weird one. Is it possible to harness energy from a black hole? What are some theoretical methods? And the funny thing is, all the answers were yes. It is possible to harness energy.
All the answers are like that. Well, yeah, I
And then
think
they go on to explain why.
I think you can harness energy because we don't know what energy is. So as long as you can say we can harness X from a black hole, I guess it's true.
Ah, it's
we
worse.
don't even know what a black hole is.
Yeah,
but
can we harness X from a Y?
Yeah, I mean,
don't know why-
that's essentially what the guy's asking. We're trying to pull a spirit out of a ghost, and
I mean, you have to know, is it possible to harness energy from a black hole? You have to know what energy means, and you have to know
what a black hole is.
is.
We don't know either.
So you could just as well have asked, is it possible to harness X from a Y?
And how much time, because we don't know what time is either. So we have all these words that we use that we don't know what they mean, and the only answer to that is we need more words to define these words, and so that's ad infinitum. You're going to keep asking, what does this word mean? What does that word mean? What does this other word that we use to define this word mean? And so on down the line. That's the way they get out of it. They say, look, we can't define every word because we always need words to define words. And that's not a good answer because we don't need to define every word in the dictionary. We just need to know what an object is, for example. And that's
At
it.
least the nouns in the.
Yeah, you need the foundations of physics. And once you establish the foundations of physics, all religions die, a sudden death.
The problem with this also is they're looking for uses, again, technology with black holes. All the answers are not only is it possible to harness energy from a black hole, it's theoretically one of the most efficient sources of energy out there. We got another guy, yep, it is possible to harness a black hole's energy, I guess he missed that word, by a process called Penrose process. It's like they're all very excited that this could be, someone could get a job doing this
In the future.
Yeah.
Your great grandson,
So it's-
maybe.
So it's kind of this hope giving thing, as opposed to what you like to do, which is kill
Destroy
people's
hope.
hopes
I
and
killed.
dreams. There was one time I finally came up with a hopeful message from your rope hypothesis,
Oh, is that
which
so?
is that we're all connected in the universe.
We're all connected.
It sounds
Yeah.
very
positive.
spiritual. Yeah,
Very positive. Yeah.
Like I can
Sell
feel,
it to
I
the
can
Buddhists.
feel Jupiter. You know.
We can sell that to the Buddhists.
Yeah, I'm connected to Jupiter. I mean, that's a cool thought.
Yeah.
I don't
That
care
is
who you are,
that.
that is a pretty
That
fantastic thought.
the Andromeda galaxy so far away is connected to us, and people kind of like that. Say, oh, that's
Yeah.
that's neat. You know,
I
I'm
think
connected
that's
to
a nice
Andromeda.
selling point, but then you come around and say, there's no.
We're gonna
moving
die,
at the
we're
speed of
gonna-
light. There's no time travel. There's no energy harnessing.
Okay, folks, we'll see you tomorrow at the same time, and we'll see if we continue with the subject or go with something else. We'll see you then. Bye bye.